Hello guys, welcome to the Michsurd Academy. So today in practical physics we are going to be looking at measurement analysis. Now in this measurement analysis we are going to see how we can measure different quantities and also the instruments that are used to measure these different quantities. Now the first one we are going to look at is the measurement of length. Okay, now length is one of the fundamental quantity. Its SI unit is in meter. All right, now the instruments that we can use to measure this, measure length, so the instruments we can use to measure length include the meter rule, the vernier caliper, and we have the micro screw gauge. Alright, for the meter rule has its reading accuracy of 1 millimeter. That's the reading accuracy of the meter rule. Then the vernier caliper is quite different from the meter rule, such a way that the vernier caliper measures the internal and external diameter of an object. Okay, so it has the reading accuracy to be 0.1 millimeter. That's the reading accuracy for the vernier caliper. So we can measure diameter of a tube using the vernier caliper. We can measure the diameter of a rod using the vernier caliper. Now the next one is the micro screw gauge. The micro screw gauge is having a higher accuracy of 0.01 millimeter, and it measures smaller diameters, okay, than the vernier caliper. So we can measure the diameter of a wire using the micro screw gauge. Alright, so the next we can think of for measurement is measurement of volume. So volume is a derived quantity in which its SI unit is in meter cube. Are we together? Alright, so in this measurement of volume we can look at two different types of solid: the regular solid, or we can also look at the irregular solid. So for the regular solid, when measuring the regular solid, we just consider the volume of that the volume formula of that solid. So like for example, if we want to check the volume of a cylinder, the volume of a cylinder has this formula to be equal to pi r square h. Okay, if it's the volume of a sphere is equal to 4/3 pi r raised to power 3. Okay, so with this formula, once we know the radius and the height, we can calculate the volume of the cylinder. Once we know the radius of the sphere, we can calculate the volume of the sphere. All right, now for the irregular solids, we use the idea of displacement of liquids. Okay, so once we have a container filled with a liquid to a particular level and we bring an irregular solid, place it inside the water, it displaces the liquid to some certain level. All right, so we try to check the increase in that volume caused by that irregular solid. So such increase in volume gives us the volume of the irregular solid. Are we together? All right, good. Now the next one we have is the measurement of mass and weight. Measurement of mass and weight. Now, mass is a fundamental quantity. Your weight is a derived quantity. Weight is normally given as mg, right? Which is mass times acceleration due to gravity. So most times we call this weight the force due to what? To gravity. All right. Now we have different instruments we can use to measuring mass and weight. Okay, so we have the lever balance and we have the beam balance. We can also have the spring balance. Okay, now for the lever balance is a direct way of measuring the weight of an object, and also it is quite simple when you compare it with the beam balance. Okay, it has a reading accuracy of 0.1 gram. All right, but the beam balance functions using the principle of moment. Are we together? It functions using the principle of what? Of moment, and it has its reading accuracy to be about 0.001 gram. Okay, now we also have that of the spring balance, which functions using the idea of Hooke's law. All right, so another measurement quantity we can look at is measurements of time. Now time is a fundamental quantity, all right, and it has its units, SI unit, to be in seconds. Now we have the instrument that can be used for measuring time to be stopwatch. We also have other instruments, but this is the one commonly used in the laboratory. Okay, so that is for the measurement of time. Now another one we have is the measurement of temperature. Measurement of temperature. Okay, now we know that temperature is also one of the fundamental quantity, and its SI unit is in Kelvin. All right, now we have different instruments we can use to measure temperature. Okay, so we have the clinical thermometer, we have the resistance thermometer, we have the maximum and minimum thermometer, and so on. We have so many of them. Okay, so we can use them to measure temperature. Another measurement quantity is the measurement of electric currents. Okay, so in the measurement of electric current, we know that the SI unit for current is in ampere. Then the instrument that we can use to measure current is called the ammeter. But if we want to measure smaller currents, we can talk about the milliammeter. Okay, for measuring smaller currents. All right, then the last one we are going to look at now is that of the potential difference. So measurement for potential difference. So the instrument we can use to measure the potential difference is called the voltmeter. Okay, it's called the voltmeter. All right, so this is where we are going to stop for today's course. And most times for the ammeter and the voltmeter, we normally place the ammeter to be in series in a circuit and the voltmeter to be parallel to the resistance of that circuit. Okay, so we are going to see a video why the ammeter should be in resistance in series to the resistance and the voltmeter to be in parallel to the resistance in a circuit. Okay, so for today we are going to stop here in this course. Thank you very much.